Okie dokie. In this lesson, we're going to take a look at the product rule. And you're going to need the product rule when the function that you're dealing with could actually be seen as two different functions multiplied together. And you want to be able to take their derivative. So this is really not too bad. It's something, again, that you just need to memorize. We're going to use it a whole lot for the rest of the year. So by the end of the year, that will be no big deal. So how do I take the derivative if I have two functions that multiply together? Well, it turns out that is the derivative of the first function times the second function, unchanged, plus the first function times the derivative of the second. Okay, so this is actually not too complicated. We're going to take the derivative of whatever our first function is and then just leave our second function unchanged. Then leave our first function unchanged and take the derivative of the second function, add those up. Now this is also because addition is commutative, which means we can change the order. It doesn't actually matter which one you go with first. So this is also equal to, switch the order, this would be fg prime plus f prime g. But for reasons that are going to become apparent when we do the quotient rule in the next lesson, it's much more handy to have this in mind and keep this order consistent, because we're going to be using that order, not exactly the same. There's going to be a subtraction, which is what makes the difference for the quotient rule. But if you keep that order in mind, then that's going to make the quotient rule a whole lot easier. So we're going to take the derivative of the first function times the second function plus the first function times the derivative of the second function. So what does that actually look like in practice? Let's take a look at the first example. I've got f of x equals 8x sine x. So I'm going to look at this as saying, well, 8x, that's going to be my f, and that's multiplied by sine x, that's going to be my g. So then in order to use this rule, I'm going to say, okay, well, if f of x is 8x, and g of x is sine x, in order to use this rule, I need to take the derivative of each of these separately. So f prime, well, the derivative of 8x is just going to be 8. And g prime, the derivative of sine x, we know is cosine x. That's one of the things you memorized. So then in order to get this f prime g plus g prime f, so I got f prime. So f prime, well in this case f prime, my function was called f, sorry that's a little confusing, but f prime of x, f prime in this case is equal to 8. G, again that's my first function not changed, so that's going to be just sine x, plus the first function 8x unchanged times g prime, what g prime was, cosine x. And that's it. You're done. There's the derivative. 8 sine x plus 8x cos x. Nothing to simplify. That's as good as it gets. Sometimes there are like terms. Sometimes there were things to play with. We could factor out an 8 if you thought that was going to make your life simpler in some future calculation, but that is totally fine as your final answer. Okay, let's take a look at another one. I've got g of x equals 2 e to the x square root x. Now, some textbooks may not use f and g because those tend to be common names for our original functions. They may make it something like u and v are actually pretty popular, like u prime v plus u v prime. The only problem with u and v is that if you're writing things very fast, u's and v's start to look very similar. So if you want to use u's and v's, if that helps you keep things straight, because we have f's and g's here, you could, well, I'm going to stick to f's and g's and just hope that you can keep straight that this g is not the same as the g I'm referring to in the formula. So here we go. I got something with an x times something else with an x. So this is going to be right here, this is my f, and this part right here is going to be my g. Sorry, this is not a division, this is just saying these things correspond. So 2 e to the x, that's my f, and root x, that's my g. Now I'm not going to go ahead and write all this out. You don't have to write this out every time, because I think most of the time, unless it's a complicated derivative for f prime or g prime, you're going to just be able to do that as you go along. So then g prime of x in this sense of the original g is, well, let's see, f prime, so my 2 e to the x derivative is just going to be still a 2 e to the x. Doesn't change because e to the x is its own derivative, times my original function g, so that's going to be times root x, plus my original function f, so that was just a 2 e to the x, times the derivative of my function g, my derivative of root x. Now this one you might need to practice a bit. So if g of x equals root x is x to the 1/2. If I want to take this derivative, I bring the 1/2 down. This is going to be 1/2 x to the, subtract 1, negative 1/2, and you could bring that to the bottom to give you 1/2 root x. I'm going to write root 2. So this is then 2 e to the x times this one. So 1 over 2 root x. Now in this case, we actually can simplify a little bit if we wanted to. So one thing that we can do is that we now have, for our second piece here, this 2 and this 2 in the denominator, they will actually cancel. So that would give me something like g prime of x equals 2 e to the x root x plus, and then this is going to be e to the x times 1 over root x, so which ends up being e to the x over root x, as an answer that is totally 100% acceptable. Now, sometimes in multiple choice questions, they might do a little bit of algebraic manipulation with it. They might, let me just clear some space. They might factor out an e to the x because they notice there's a common factor of e to the x. So a multiple choice question, you might need to be able to recognize this is the same thing. If you pull out an e to the x, then I've got 2 root x plus 1 over root x. They might do that. They might also put these over a common denominator and add them together by making this over root x. Isn't really necessary. This second line here is totally fine as your answer as being simplified, as simple as it gets. Just if it's a multiple choice question, you might need to be able to recognize if they've done some more algebraic manipulation. Now, one thing that, again, you don't have to write this down, but just kind of a reminder, maybe I'll write it down here where I've got a little bit of space. If I have a function like h at x equals 6 sine x, sometimes students are tempted to take this as a product rule. They're like, well, this is a 6 times a sine x. And you could look at it that way, but the thing is when you take the derivative of 6, it just ends up being 0, and then it's going to be 0 times this, and all I'm left with is this. And so, while we recognize this is actually the constant multiple rule, it would be way simpler to just say, well, the 6 he just hangs out in front, and the derivative would just be simply 6 cos x, which is actually this part of our formula, if you're thinking about the fact that the 6 is the f, and g prime is the derivative of sine is cos. So you could treat this like a product rule, but why would you want to? It's just a constant multiple rule, and that makes our life simpler. So again, we tend to do the product rule when our thing in front, or when both of our functions have an x involved. If there's no x here, then the derivative is just going to be 0, so it's going to make this part disappear. So we need 2 functions with x, and that's what we're looking for in our third example. So in this case, each of our parentheses is going to be one of our functions. So this is going to be our function f. This is going to be our function g. So then h prime is going to be, well, the derivative of f. So you might need to come around somewhere else and do the derivative of 1 over x. So 1 over x is actually equal to x to the minus 1, bring that down in front, that gives you negative x to the minus 2, or negative 1 over x squared. So the derivative of f then is going to be negative 1 over x squared. The derivative of 1 is just 0, so that part just disappears. Then I just write my g all by itself the same way that it is, plus, now I write my f the way it was, and I take the derivative of g. Well, the derivative of g, that's easy to see. Bring the 2 down. This gives me a 4x, and the derivative of 5, again, just disappears. Now, you can kind of look ahead to see if this is actually going to help me, I think, to expand this, to make it a little simpler. In this case, it does. We can get rid of some parentheses, collect some like terms. So I'm going to go ahead and do that. So I've got this negative x squared times 2x squared. So negative 1 over x squared times 2x squared is going to be just a negative 2. That's kind of nice. Negative 1 over x squared times negative 5 is going to be a positive 5 over x squared. And I've got now 4x times 1 over x is going to be plus 4. And 4x times 1 is going to be plus 4x. So there I've got some like terms. I've got the negative 2 and the 4. I can collect those. It doesn't really matter what order you write these in, so I'll just keep those first. So 2 plus 5 over x squared plus 4x. And that would be my simplified answer. It does look a little simpler, neater, nicer than the one with all the parentheses in it. All right, so that's the basic idea. And of course, we can apply that to tables. This is basically a straight up application of the formula. Here we go. So we've got h of x equals 3 f of x, g of x, And what I'm looking for right now is h prime of 2. So first I'm going to just write out what the general derivative would be, and then I'm going to figure out exactly what it will look like at 2. So then h prime of x, I'm just going to keep that 3 in front as like a constant multiple and take the derivative of this part. Now this is already written f of g, so this is going to be f prime g plus f g prime. And when I want to find that h prime of 2, then it's going to be h prime of 2 is 3 f prime of 2 g of 2 plus f of 2 g prime of 2. And at this point, it's just a matter of looking straight up into my table. So f prime of 2, so here's my x value of 2. F prime is negative 2. G of 2, so 2, G of 2, negative 1. F of 2, so that is 4. And G prime of 2 is 2. And I can just simplify that up. So I've got here, negative 2 times 1 is 2, plus 2 times 4 is 8, 2 plus 8 is 10, so 3 times 10 is 30. And there I've got it, h prime of 2 is 30. So again, just a matter of applying the rules and then looking up your numbers in a table to plug into whatever you get. So why don't you go ahead and pause your video now and try number 5, and I'm going to also pause my recording and do it off screen and then come back and check how you did. Alright, so here we go. Each of your parentheses, again, is considered your f and g for the purposes of our formula. So we want to take the derivative of this first one, write the second one the same, then write the first one the same, then the derivative of the second one. And that's what it ends up looking like. That half, or the 2 on the bottom is just like a constant multiplier. It can just stay on the bottom, and the constants, their derivatives are going to end up being zeros every time. So kind of check your work. If you actually skip and don't write down this second line, if that seems pretty obvious to you, then go ahead and just skip right to here. That is totally okay, because that's just the part that says I'm doing it at -5, and that's what I'm doing with the table. But if it helps you to remember what this means, why in the world I'm plugging in different values, go ahead and write it. That's totally fine. Alrighty, that's all for this lesson. Good luck with your master check.